Okay, guys, realized that the YouTube playlists are a little out of date, uh, but it's essentially fine. Now, your data may look a little different. In this case, we just did 5 periods. So, what you could imagine is that you could have, let me see, pause for a moment. All right, so in class we did something like this. T for n periods, and then you decided uh, to have some plus minus. Now we should always make a habit of units. And then in this particular example, it just happened to be 5 every time. And of course, that would be an integer. So there'd be no decimal places. Let's see, center this, make that look pretty. So then the period is going to equal the time that we took for 5 periods, and then n periods divided by n, because this is what I asked you guys to do in class. So there we go. And different plus minuses here. I think I fudged these a little bit just to make the data look more reasonable. I can't even remember if this is real data or not, but I know it's reasonable. Okay. So with the plus minus, we do a similar thing, and I guess you just divide by and somehow I think it's the square root. In fact, I'm going to pause once again. Okay, so did it by the numbers. If I say t, the period is equal, t for 5 periods divided by 5. So then a becomes t sub n and b is 5. There's no plus minus of 5, so that term is 0. And for us, sigma AB is always equal to 0. So we're just left with the first term. And then at the end of the day, it's just the period times the relative error of the plus minus t sub n, right? So let's see if that makes any difference. So equals the period times the plus minus t sub n divided by t sub n. Yeah, it's basically the same thing. I have to see. It's probably simply divided by 5. I gotta check it out. But we'll just do it by the numbers. We notice there's no difference, but at least we can feel confident that we got it right. Okay. So now we take the logarithm base 10 of L. And then the logarithm base 10 of the period. And then we need the plus minus logarithm. And even if it's, and you'll see our other equation here, and little a is equal to 1. So at the end of the day, this becomes the plus minus log t equals the plus minus on the period. Divided by the period itself times the natural log of 10. And that's weird. I looked it up because I just didn't believe it. But lo and behold, I don't know why we used the natural log, but it has something to do with, if you do natural log of 10, then it's something that relates it back to the base 10 logarithm. So then we see that right there. And then, so I've already made a graph here. It's pretty easy with this time because you can just select those two and you're ready to go. And so I wonder if there is a better way to set this up, because we know how to do, let's see, insert, and I suppose we can just go straight to the res squared. We know what residuals are. So that's going to equal always got to make it in parentheses. And so we're putting log t is onto the y-axis. So that's the data minus the fit. And then we square it. There we go. And then we have the sum of the res squared. And we're going to add something new today, the sum of chi-square, and that's just some fancy words. And so let's I got some ideas here. Let me pause for a minute. Okay, so now I cleaned her up quite a bit. Make our lives a little easier. And I've got this guy going on. And oh yeah, it's still in this lasso select. And let's see. So fit line, that's got to be an equation. It's not at the moment. Excuse me. And let's cancel. So this is going to equal the slope f4 times let's see, in this case this is the x-axis plus some y-intercept 4. And now we have something that's not just some numbers. Neat. And oh yeah, and the chi-square. Chi-square is just the res squared divided by the plus minus of the error bar. That's all. Okay. Equals the res square divided by the plus minus squared, and this just is a way of downplaying. You'll notice that the smaller is the error bar, the bigger is that chi-square amount. And this way, the bigger error bars contribute less than the small error bars. Right? See, this is a really small error bar there. So we can let's add an error bar. And we don't have any fancy, this kind of pain in the butt because we can't just add X or Y. We have to add in both of them, which is the PITA. So the X error bars are just going to be 0. And then the Y error bars are going to be these calculated values. All right. And so there we see our data with error bars. And certainly this is log T versus log L, just so we remember. Whoops. And we need to add the fit line. Select data. Add, the series name is fit line. I suppose we could get clever about that. And there's our log L. And there's our fit line. And okay. And we need to solid line. And, you can put any color you want. And what else? No marker. None. Okay, we're on our way. So, all borders. And so equals sum of the residual squared. And then equals the sum of these guys, chi-square numbers. And now we'll use the solver to, oh, what's wrong? It's seemingly unhappy. Why? Oh, well. So minimizing the sum of the chi-square this time. Min by changing the slope and the y-intercept. Whoops. There we go. And make sure that they can go negative. Let's just check. And there you go. Now, it didn't quite pick up that error bar, but it does show you, though, that the point with the large error bar stays, is not that close to the fit. And if you look, in this case, if I looked at only the residuals, that for sure the sum of the residuals is going to be negative because that one point is so far below. But that's okay because now it has a large error bar. Up till now, and even in this lab probably, the error bars are going to be pretty much the same. So any error introduced by not taking into account, it's not that big of a deal because the sum of the residuals and residuals squared won't be changed a whole lot if all the error bars would be equal. But because they're not, then it's really a good idea to use the sum of the chi-squares. There we go, or just use chi-square. Okay, so of course, the slope and the y-intercept are equal to certain things. And so part of the challenge here is to take these numbers, and let's just refer to it for a minute. Where is, be Acrobat. Here we go. And here we go, lab manual. So, pretty much spell it out to you, right? So you can turn that into A equals, and A, well, in our case, we're calling it y-intercept, right? And then here, our B, now give me a minute here. Right. So B, 1/2, the slope should be 1/2, huh? Interesting. Is it? Oh my goodness, look at that. Bingo. So now we just got to double check the that quantity and leave that for you. Okay. Let's see. Maybe I'll stop this one and just upload it as the length and period log. Yeah. I'll be back.